Assalamualaikum guys, I hope everyone is fine. At present I have 24 students, so I think we need to wait a few more minutes before we start the class. Equations, we derived the equations and then we have solved the numerical to calculate the orientation of the principal planes, orientation of the shear plane, magnitude or computation of the, you can say, principal shear strains, maximum in plane shear strain. Then we also use the equations to calculate the normal and the transform normal and shear strain at any given orientation. Then we also studied about the Mohrs circle. Fine. So now, just like in the case of the stress transformation, first we did the derivation of the equations. Then in the second step, we studied the Mohr circle. So now in the third step, we are going to study the absolute shear strain. Just like
excuse me sir.
जी
सर काइंडली रिकॉर्डिंग इनेबल कर दें ताकि बाद में एक्सेस हो सके लेक्चर की.
अभी मैंने रिकॉर्डिंग लेक्चर स्टार्ट नहीं किया इसलिए नहीं ऑन किया सर.
ओके सर, थैंक यू.
So today we will start with, today we are going to study two topics. One is absolute shear strain, which will be very much similar to the absolute shear stress. And the second topic is strain rosette. Strain rosette is basically a technique. So I will discuss about the strain rosette once we study that. So let's start with our today's lectures. Okay, Bismillahirrahmanirrahim. Let's start. So the first topic which we are going to study today is absolute shear strain. So if you recall, in case of absolute maximum shear stress, we said that in case of plane stress, we said that we have two principal stresses, sigma 1 and sigma 2. Sigma 1 was oriented about x-axis, sigma 2 was oriented about y-axis, and there was no principal stress about the z-axis because we are working in biaxial stress strain or plane stress state. And then we derived the equation, if you recall, in the case when both the principal stresses were positive. When both the principal stresses were positive, means they were tensile stresses and they were producing what you say tension. So in that case, if you recall, we found out that the absolute maximum shear stress is sigma 1 over 2 and the maximum in plane shear stress. Maximum in plane shear stress will involve both sigma 1 and sigma 2. So maximum in plane shear stress, sigma 1 and sigma 2 was sigma 1 minus sigma 2 over 2. So I repeat, in case of both principal stresses either positive, means they are either tensile, or negative, means compressive. Absolute maximum shear stress was sigma 1 over 2 and maximum in plane shear stress was sigma 1 minus sigma 2 over 2. Now in this case of absolute maximum shear strain, when either both of your principal strains will either be positive or negative. Positive means they are the tensile strains causing the elongation in the element, or the negative strains, or both are negative strains, means they are causing the contraction in the element, or they are compressive strains. So in that case, you will see that the absolute maximum shear strain, as you can see here, is epsilon 1. The difference is because over here in the on the vertical axis you have gamma by 2. So basically it becomes gamma by 2 is equal to epsilon 1 over 2. So 2 will cancel out and you will get epsilon 1. So basically in the denominator you had 2 in the case of shear stresses. But in case of shear strains, you will not have a denominator. ठीक है जी. So absolute maximum shear strain will become epsilon 1. ठीक है. And maximum in plane shear strain will become epsilon 1 minus epsilon 2. ठीक है जी. There will be what you say, there will be no what you say 2 in the denominator in this case. So let's start now. So in section 9.5, that is they are referring to your what you say absolute maximum shear stress topic. It was pointed out that in case of the plane stress, the absolute maximum shear stress in an element of a material will occur out of the plane when the principal stresses have the same sign. So if you recall in your case 1 of the what you say absolute maximum shear stress, for the case 1 when both your tensile stresses were positive, means tensile stresses, you remember that in that case your absolute maximum shear stress and maximum in plane shear stress, they were different. Absolute maximum shear stress was this one. If you just see this figure and instead of taking it as strain, you just take it stress, so it's exactly the same. And if you recall, this was your absolute maximum shear stress and this was your maximum in plane shear stress. So that's what they are writing it over here, that maximum shear stress in an element of material will occur out of the plane. This is the plane X and Y. So it was out of the plane because it was acting, your absolute maximum shear stress was acting in the plane XZ, which is considered out of the plane. In plane is this X and Y. ठीक है जी. A similar test result, a similar result occurs for the plane strain. ठीक है जी. So in case of the plane strain, if we just focus on this figure now. So if you see this, this is your element. ठीक है जी. 3-dimensional element. And this is your x-axis, this is your y-axis, this is your z-axis. And if you see, we have a principal strain along the x and y-axis, but we have no strain about the z-axis. Because we are working in 2 dimension, x and y. And then corresponding to these elements, with these principal strains, we have drawn this Mohrs circle. So let's start the Mohrs circle. If we draw the Mohrs circle for, let's say, first y and z plane, and we know that in y and z plane there is only a principal strain that will be y2. There will be only principal strain about epsilon 2 about the y-axis, and there is no principal strain about the z-axis. So if I draw the Mohrs circle corresponding to yz axis, 0 and epsilon 2. Again, just another thing to be remembered, that just like that sigma 1 will always be greater than sigma 2. So similarly here, in case of the strains, principal strains, epsilon 1 will always be greater than epsilon 2. So for YZ plane, you have 0 principal strain about z-axis and you have epsilon 2 about the y-axis. So this Mohrs circle 0 to epsilon 2, this Mohrs circle we have drawn for corresponding y and z plane, this Mohrs circle. And you can see 0 to epsilon 2. So in plane shear strain for this Mohrs circle, gamma yz over 2 will be epsilon 2 minus 0 over 2. So gamma yz over 2 will be equal to epsilon 2 over 2. Then we will draw the Mohrs circle for the Mohrs circle for this plane z and x. And you know that in case of the x, you have sigma epsilon 1, and there is no principal strain about the z-axis. So for epsilon 1 and 0, so starting from 0, and this is your epsilon 1. So this outer Mohrs circle is basically representing your xz plane. And if we want to find the maximum in plane shear strain for xz plane, So you will see 0, epsilon 1. ठीक है जी. So this one xz. So gamma xz over 2 will be equal to epsilon 1 minus 0 over 2. So gamma xz over 2 will be epsilon 1 minus 0 over 2. And for the third case, x and y. So along the x we have epsilon 1, along the y we have epsilon 2. So this Mohrs circle, epsilon 1 and epsilon 2. So this Mohrs circle will be drawn to connect epsilon 1 with epsilon 2. So for this, corresponding to this Mohrs circle, your in-plane shear strain will be gamma xy over 2 will be equal to epsilon 1 minus epsilon 2 over 2. So gamma xy over 2 is equal to epsilon 1 minus epsilon 2 over 2. And if you see, the larger of the three will be over absolute maximum shear strength. So from the figure we can see that this one gamma xz over 2, that is epsilon 1 over 2, is over absolute maximum shear strength, and this is xz plane. So this is out of the plane. So absolute maximum shear strain is equal to gamma xz dash over 2, which is equal to epsilon 1 over 2. So 2 will cancel out. So absolute maximum shear strain will be equal to epsilon 1. ठीक है जी. And maximum in plane shear strain will be for xy plane will be the one which will include both epsilon 1 and epsilon 2. So epsilon 1 minus epsilon 2 over 2 will be your gamma xy over 2, which is your maximum in plane shear strain. Now remember one thing, this 2 and epsilon 1 minus epsilon 2 over 2 in the denominator will cancel out. So you will get maximum in plane shear strain gamma xy as epsilon 1 minus epsilon 2. ठीक है जी. Now one thing to be noted, that this is the case when either both of your principal strains are positive. You can see over here in this case they were positive. There was elongation in the element. Find 1 plus epsilon 2, 1 plus epsilon 1. So there was elongation in the element. Or the second scenario is if both of your planes, if both of your principal strains are negative. If I will have negative strains, then whole of this figure will move to the negative side, but you will still get the same values of absolute maximum shear strain and the maximum in plane shear strain. ठीक है जी. So for the case 1, when both of our what you say principal strains are either positive or negative, or you can say they have the same strain, in that case we will get this absolute maximum shear strain as epsilon 1 and maximum in plane shear strain as epsilon 1 minus epsilon 2. If you have any question, please ask me now. Any questions? If it is clear, then we are proceeding forward. Clear? If not clear.
Yes, sir.
Okay, now next case is when one of your principal strains is negative. You can see this. 1 minus So that's why in the book as well, they are just giving you that the absolute maximum shear strain will be equal to the maximum in-plane shear strain. That will be equal to epsilon 1 minus epsilon 2. And this is the scenario when epsilon 1 is positive and epsilon 2 is negative. If you have any question, please let me know. Otherwise, we will start the numerical related to this. Remember. So this is revision. The absolute maximum shear strain will be larger than the maximum in-plane shear strain whenever the in-plane principal strains have the same sign. So that's we have seen earlier here as well. They are saying this that this is your absolute maximum shear strain. This is your maximum in-plane shear strain, and it is obvious from the figure that absolute maximum shear strain is greater than maximum in plane shear strain. 50 micro strains. So in the question it is asked to determine the maximum in-plane shear strain and the absolute maximum shear strain. So in the question, we need to calculate maximum in-plane shear strain and the absolute maximum shear strain. So what will be our first step? We are given the state of the plane strain, epsilon x, epsilon y, and gamma y. We are given the state of the plane strain, and we are required to calculate the maximum in-plane shear strain and the absolute maximum shear strain. So in this case, what we have to do first? जी बताएं कि पहले क्या करना है? जी, what will be our first step? First step is see, we have to calculate the principal strains. We do not have the values of the principal strains. So first I need to calculate epsilon 1 and epsilon 2. Then I can determine this maximum implant shear strain and the absolute maximum shear strain. So first step is I need to calculate principal strains. I need to calculate the principal strains. So in this question, it is not given that whether we have to calculate the principal strains with the help of the Mohrs circle or with the help of the direct equations. So for the practice, we can draw both. Okay, we can go with the Mohrs circle and we can also use the equations as well. So first step is to, in the drawing of the Mohrs circle, the first step is that we need to calculate the average strain. Okay, the first is you need to determine the coordinates of point C. Then you need to determine the coordinates of point A, which is your reference point A. Then you need to compute the resultant or the radius of the Mohrs circle. And then you will select the scale. First you will locate the point C, then you will locate the point A, you will connect C to A, you will place your compass at C, open up equal to line CA and draw the Mohrs circle. And where's your Mohrs circle? What you say cuts the horizontal normal strain axis. Those 2 points, the larger will be principal strain epsilon 1 and the smaller one will be epsilon 2. So let's start. So first step is you need to calculate the average normal strain. So please calculate average normal strain. So we solve this problem using Mohrs circle. Okay, we are also going, but we are going with both methods. So first, please calculate average normal strain. Epsilon average is equal to epsilon x plus epsilon y over 2. Epsilon x is minus 400 microstrains. Epsilon y is 200 microstrains. So average is minus 400 plus 200, 200 divided by 2, minus 100 microstrains. So average strain is G. Everyone is getting this answer, average strain?
Yes, sir.
Okay. So coordinates of your point C will be average strain, average strain and shear strain. Average strain is minus 100 microstrains. Shear strain is 0. So coordinates of point C are minus 100 and 0. Now next thing is we need to determine the coordinates of point A. Coordinates of point A. So epsilon x is minus 400. So epsilon x is minus 400 microstrains and gamma xy over 2 will be 75 microstrains. Gamma xy over 2 will be 75 microstrains. So coordinates of your point A, which is your reference point, has the coordinates gamma x, which is minus 400 microstrains, and gamma xy by 2, which is 75 microstrains. So reference point A coordinates are clear?
Yes, sir. Yes.
Okay, now next thing is you need to calculate the radius. ठीक है जी, you need to calculate the radius or the resultant of the Mohr circle. So radius or the resultant is formula is under root epsilon x minus epsilon y over 2 square plus gamma x y over 2 square. I repeat, radius is under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So please calculate the radius and let me know the answer.
Sir, it's 309.2 micron.
In the case of the strings, you can see it is 309 into 10 raised power minus 6. 309 into 10 raised power minus 6. ठीक है जी, which means 0.000309. ठीक है जी, so I would prefer if you just keep it to one decimal place, 309.2 micro strings. ठीक है जी, 309.2 micro strings, 10 raised power minus 6. ठीक है जी, micro strings means 10 raised power minus 6. So 309.2 micron strings. ठीक है जी. Now next step is you have the radius now. So if you are drawing the Mohrs circle, you can draw the Mohrs circle, and other way around is even like if I want to save time here, what I can do, I know that epsilon 1 principal strain epsilon 1 will be equal to average strain plus the radius. ठीक है, average strain plus the radius, and epsilon 2 will be average strain minus the radius. ठीक है जी, minus the radius. So can you let me know these two values? Epsilon average plus R. So this will be 209 microstrains, and epsilon average minus R will be minus 409 microstrains. So if you want to draw the Mohrs circle, you can draw the Mohrs circle as well. ठीक है जी. So epsilon 1 I am getting average strain plus the radius. Epsilon 2 is average strain minus the radius. So minus 100 plus 309 is 209. Minus 100 minus 309 is minus 409 microstrains. Is this clear?
Yes, sir.
So epsilon 1 is 209 microstrains. Epsilon 2 is minus 409 microstrains. ठीक है जी. Now you can see your epsilon 1 is positive, epsilon 2 is negative. ठीक है जी. Epsilon 1 is positive 209 microstrains, and epsilon 2 is negative minus 409 microstrains. ठीक है. Now it means this is the case where one of the principal strains is positive and another one is negative. So in that case, if we want to calculate the absolute maximum shear strain or the maximum in plane shear strain, they both will be have same values. So absolute and the maximum in plane shear strain can be determined as epsilon 1 minus epsilon 2. If you are doing it in the paper and you are not sure whether the formula is this one, then you have these principal strains. You can draw this Mohrs circle. You can see this. They have drawn the Mohrs circles. And then from here they have calculated the maximum implant shear strain and absolute shear strain, which is epsilon 1 minus epsilon 2 over 2, and it is equal to gamma xy over 2. So 2 will cancel out. So basically it will be epsilon 1 minus epsilon 2. Okay, so epsilon 1 minus epsilon 2. So maximum in plane shear strain is epsilon 1 is 209 microstrains minus, and epsilon 2 is minus 409 microstrains. So the net value maximum in plane shear strain we got as 618 microstrains. Is this fine? If you have any query, please ask me now. जी. If you have any query about this numerical, you can ask me. No query?
No, sir.
Okay. Okay, so our next topic is strain rosette. Okay, so we can have a short break of 10 minutes and we will restart the class at 9:55. Okay, and we will start with the strain rosette. Did you guys study this strain rosette, about the strain rosette in the lab class? आप लोगों ने have you studied about the strain rosette in your lab class or no?
No, sir.
Okay, ठीक है. We will cover it over here. Okay, we will have a short break and we will restart at 9:55. Let's start recording. So, strain rosette. Earlier we have said that when we will attach a strain gauge, let me explain you a few things with the on the whiteboard first. First, earlier we have said that when we will attach a strain gauge, it will measure the strain only in that particular direction. It will not measure the strain in the perpendicular direction. Now let's see. This is your beam, longitudinal section I am drawing. Now on this longitudinal section, this is the continuity sign. This is my strain gauge, which is attached in the longitudinal direction. And this is my strain gauge, which is attached in the perpendicular direction. So I have attached two strain gauges on the beam. One along the longitudinal direction and the other along the transverse direction. So this strain gauge, which is drawn with a black color, that will only measure the strain in the longitudinal direction. And this strain gauge, which is attached in the transverse direction, it will only measure the strain in transverse direction. Is this clear? So strain gauge will only measure the strain in the direction in which it is attached. It will not measure the strains in transverse direction or perpendicular directions. ठीक है जी? In 3 dimension we said, let's say this is epsilon x. ठीक है जी? Strain gauge which is measuring epsilon x. ठीक है जी? This strain gauge will only measure the strain in the longitudinal direction. Let's say this is epsilon x. It will not measure the strain in y direction or z direction. ठीक है जी? It will not measure the strain in y or z direction. Similarly, now you see here this strain gauge, it will only measure the strain in y direction. ठीक है जी? Epsilon y. It will not measure the strain in other 2 directions. ठीक है जी? It will not measure the strain in the other 2 directions. ठीक है? So strain gauge will only measure the strain in the direction in which it is attached. Strain gauge will not measure the strain in other directions. ठीक है? This is the general concept of the strain gauge. Only measure the normal strain in the direction in which it is attached. Now comes the strain rosette. So what is strain rosette? Strain rosette is basically a group of strain gauges. ठीक है जी? Let's say this is one point, ठीक है, on the element, and we have placed 3 strain gauges. 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 Let's say this is strain gauge A. This is strain gauge C. Now, to our understanding, this will measure strain gauge in this direction, only in this direction. ठीक है जी? Let's say this measures strain gauge A. This gauge, strain gauge B, measures strain epsilon B. ठीक है जी? This measures strain in C direction. Let's say it measures C. ठीक है जी? So this is one particular, you can say, a strain rosette. So then with respect to horizontal axis, ठीक है जी, we need to measure its theta. ठीक है जी? Let's say this is theta A. This is theta B. And this is theta C. Just remember one thing, that our reference remains the same, and it should be positive x-axis. ठीक है? So this is positive theta B, this is positive theta C, this is negative theta A. ठीक है? Negative theta A. So now from the strain rosette, you have epsilon A, epsilon B, epsilon C, theta A, theta B, theta C. Now your target is you want to calculate the plane state of strain. You need to measure the plane state of strain. You need to measure the plane state of strain. ठीक है जी? So our target is to get these values, plane state of the strain, ठीक है जी, and then from the plane state of the strain we can calculate principal strains, ठीक है जी, we can calculate principal strains, we can calculate gamma xy absolute maximum or maximum in plane shear strains, ठीक है जी. So see, strain rosette is group or set of strain gauges arranged in particular pattern. So these thetas will be different for different cases. ठीक है? Each strain gauge gives you one value of strains: epsilon A, epsilon B, epsilon C. These are the thetas. Now we will develop the equations, and then based on those equations, what we want to do, we want to calculate this. ठीक है जी? Normal and shear strain, which is your plane strain state, and from here we want to calculate epsilon 1, epsilon 2, ठीक है जी, whatever you need you can calculate it. Is this point clear?
Sir, I have a question. सर हमने रेफरेंस लाइन से थीटा पी और थीटा सी काउंटर क्लॉकवाइज डायरेक्शन में मेजर किए, तो थीटा ए क्लॉकवाइज में क्यों किया?
ठीक है, दैट्स करेक्ट. थीटा बी आपका विद रेफरेंस वी आर टेकिंग 90 डिग्री, ठीक है जी, पॉजिटिव है ये, तो पॉजिटिव 90. थीटा सी will be positive 180 degrees. Theta A. थीटा ए अगर हम उसी रेफरेंस से लेंगे तो थीटा ए विल बी समवेयर यू कैन से 90, 180, 270. तो अगर हम लें उसी एंगल से तो दैट वुड बी समवेयर हियर. लेट्स से ये 45 डिग्री है, ठीक है, दिस इज 45 डिग्री. सो 270 प्लस 45 इज 315 डिग्री. तो ये पॉजिटिव आएगा. और if we take negative, it will be minus 45, ठीक है जी. So minus 45 and it will give you the same answer as 350, ठीक है जी. So the reference is same. So what we are doing with reference to A, I am taking it 45 degrees clockwise. So that will become minus 45 degrees. ठीक है जी. So when we will put this value in the equation, we will get the same answers. ठीक है. Is this point clear? So let's come to the slide. One thing you have to do, you need to check this one as well. आप ऐसे करें, आप फाइंड करें sin 315, cos 315, sin of minus 45, sin of minus cos of minus 45, and let me know whether you are getting the same answers or not.
Yes sir, the answers are exactly same.
ठीक है. Clockwise is negative, counterclockwise is positive. Okay, now let's start here. So strain rosette, when performing a tension test on a specimen, The normal strain in the material is measured using an electrical resistance strain gauges. Electrical resistance strain gauges. There are different types of the strain gauges nowadays. Nowadays, but the most common, most what you say, accurate and easy to use is this electrical resistance strain gauge, which is the working principle of this electrical resistance strain gauge is Wheatstone bridge. ठीक है जी? So this electrical resistance strain gauge, it consists of a wire grid or piece of metal bonded to the specimen. So this is the what you say, the wire grid, okay, and this is the metal base, okay, and these are the connections. So along with this, we will have the wires, okay, and those wires, one end will be connected to the strain gauge, other end will be connected to the data acquisition system in which your data will be recorded. ठीक है जी? So these strain gauges, they will only measure the strain in the direction in which they are attached. ठीक है? So for a general loading on a body, however, the strains at a point on its free surface are determined using a cluster of 3 electrical resistance strain gauges. Commonly, a cluster comprises of 3 strain gauges, but I have seen a case in which there were 4 strain gauges as well. But for the time being, we will limit ourselves to the 3 strain gauges arranged in a specified pattern. This theta A, B, C, they can be any values. In the practice problem, you can see they have given you different values of theta. So theta can vary. Fine. So for a general loading on a body, however, the strains at a point on its free surface are determined using a cluster of 3 electrical resistance strain gauges arranged in a specified manner. This specified manner is referred to as strain rosette. And once the normal strains on the 3 strain gauges are measured, as strain rosette, and once the normal strains on the 3 strain gauges are measured, the data can then be transformed. To specify the state of the strain at the point. So state of the strain at the point means that strain rosette, it is measuring epsilon A, this is measuring epsilon B, this is measuring epsilon C. Theta A, theta B, theta C are known to us. Now we want to find from all this data what we want to find. We want to find epsilon X, epsilon Y, and gamma XY, which is over state of the plane strain. And once the normal strains on these strain gauges are measured, because I have told you that it will only measure the strain gauge will only measure the strain in the direction in which it is attached. So it is attached in, let's say, this direction, it will only measure normal strain. It's not going to measure perpendicular strains or the shear strain. So since these strains are measured only in the plane of the strain gauge, and since the body is stress-free on its surface, the strain gauges may be subjected to plane stress. But not the plane strain. As we have studied earlier, that to achieve plane strain state, we need to make an assumption that the Poisson's ratio is 0. So although the strain normal to the surface is not measured, realize that the out of plane displacement caused by this strain will not affect the in plane measurements of the gauges. Because the strain gauges, they are only measuring the normal strain, it will not affect the strain in the other direction. Fine. Out of plane displacements caused by this strain will not affect the in plane measurements of the gauges. Now see this, in the general case, the axis of 3 gauges, the axes of the three strain gauges are arranged at the angles theta A, theta B, theta C. With reference to this positive x-axis, we will move in counterclockwise direction. ठीक है जी? Counterclockwise is positive theta A, theta B, theta C. ठीक है जी? If the readings of the strain gauges are epsilon A, epsilon B, and epsilon C, we can determine the strain components epsilon X, epsilon Y, gamma XY at the point by applying the strain transformation equation. ठीक है जी? Now, how we will do it? So this equation, you guys have developed it. This one. Let me show this. So if you recall in your derivation of epsilon x dash, in the derivation of your epsilon x dash, ठीक है जी, ये epsilon x dash, the derivation which we have done, there was, before we place the identity, ठीक है जी, the final equation is this one. Epsilon x dash is epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cos 2 theta plus gamma x y over 2 sin 2 theta. So in this case, this is our final equation. But our equation before the simplification, or you can say before putting the identities, we got this equation. Epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus gamma xy sin theta. This, so in this, what you say, this strain Rosette, they are using this equation. Okay, the epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus gamma xy sin theta cos theta. So now you see this. In this, these are three equations corresponding to three strain gauges and three values of theta. So epsilon x dash is replaced with epsilon A here. Epsilon x cos square theta A plus epsilon y sin square theta A plus gamma xy sin theta A cos theta. Now in the next equation, they have x dash with epsilon b value. So epsilon x cos square theta b plus epsilon y sin square theta b plus gamma xy sin theta b cos theta b. And in the third one, epsilon c is equal to epsilon x cos square theta c plus epsilon y sin square theta c plus gamma xy sin theta c cos theta c. Now these three equations are clear. These three equations. Any question about this, please ask me. If it is clear, then see this. In these three equations, you have epsilon A, epsilon B, epsilon C. You have theta A, you have theta B, you have theta C. So only unknown is now epsilon X, epsilon Y, and gamma xy. So solving these three equations with particular set of theta A, theta B, theta C, epsilon A, epsilon B, and epsilon C, you will get your plane state of the strain, that is epsilon X, epsilon Y, and gamma XY. ठीक है जी? So that will be your plane state of the strain, epsilon X, epsilon Y, and gamma XY. Fine. So let's move further. Any questions? Any questions? No questions? Okay. Then the values of epsilon x, epsilon y, gamma xy, which is over plane state of strain, they can be determined by solving these three equations simultaneously. Okay? Now over here, this onwards, they have given you, or they have for two common what you say strain rosettes. One is 45-degree strain rosette, other is 60-degree strain rosette. So for these two commonly used strain rosettes, they have given you the equations to calculate epsilon x, epsilon y, and gamma xy. There is no need to remember these equations. You just need to keep this equation in your mind. Okay? So whatever value of theta will be given, you can simply put the value of theta and you can simplify. So here they are explaining two strain rosettes. One is 45 degrees. In 45 degrees, you can see this is your strain rosette gauge A. This is your strain gauge B. This is your strain C. So strain gauge A, strain gauge B, strain gauge C. Now taking the theta with reference to positive x-axis, taking the theta with reference to positive x-axis, theta A is 0 degrees, theta B 0 to 45, positive 45. And theta C is 0 to 90 degrees. Theta C is 90 degrees. So with this 45 degree strain rosette, theta A is 0, theta B is 45 degrees, theta C is 90 degrees. Okay? And epsilon A, epsilon B, epsilon C. Okay? So now you can see this in the case of 45 degrees or rectangular strain rosette. 45 degree strain rosette is also called as rectangular strain rosette. Theta A is 0, theta B 45, theta C 90. Now A, B, and theta A, theta B, theta C values have been put in these equations in equation 1016 and they are simplified. When you will simplify, you will get this equation. Epsilon x is equal to epsilon A, epsilon y is equal to epsilon C, gamma xy is equal to 2 times epsilon B minus epsilon A plus epsilon C. So this is the simplified version by putting the value of theta A 0, theta B 45, theta C 90 in this equation 1016. You got this. Okay? No need to remember these equations. Just keep this equation in your mind, and then for any given strain rosette, you can get these results. Then there is another strain rosette which is 60-degree strain rosette. In 60-degree strain rosette, we have this theta A with reference to positive x-axis is 0. Theta B with reference to positive x-axis is positive 60, and theta C with reference to positive x-axis is 120 degrees. 120 degrees. Okay, so you can see this theta is 0, theta B is 60 degrees, theta C is 120 degrees. Okay, theta A is 0 degrees, theta B is 60 degrees, and theta C is 120 degrees. If you have any question, please ask me now. And again, these theta A, B, C values have been put in equation 16, 10, 16 and simplified. Again, I will suggest you not to remember this equation or this equation. Just focus on your equation 10, 16. And whatever is the pattern given to you, you can just simply put the values of theta. You can simplify it and you can get these expressions. So for 60-degree strain gauge, theta A is 0 degrees, theta B 60 degrees, theta C is 120 degrees. So epsilon x is equal to epsilon A, epsilon y is equal to 1 over 3 times 2 times epsilon B plus 2 times epsilon C minus epsilon A. Gamma xy is equal to 2 under root 3 times epsilon B minus epsilon C. If you see this, sorry. So once epsilon x, epsilon y, and gamma xy are known to you or determined. The transformation equations which we have studied at the start or the Mohr circle, they can be used to determine the principal in-plane strains and the maximum in-plane shear strain. If you have any question, please ask me now. And any question? Strain Rosette solution is clear to everyone? Clear?
Yes, sir. Yes.
If this is clear, then we are heading towards the numerical. So numerical is example 10.8. Numerical is 10.8. So the statement is the state of the strain at point A. The state of the strain at point A, this is your point A, and at point A you have a strain rosette. So this is A, B, C. So this is your strain rosette comprising of cluster of 3 strain gauges. The cluster of 3 strain gauges. So the state of the strain at a point A on the bracket is shown in figure 1017 is measured using the strain rosette shown in the figure 1017b. So figure 1017b is this is the strain rosette. Theta A with reference to positive x-axis is 0. Theta B with reference to positive x-axis is 60. Theta C with reference to positive x-axis is 120 degrees. Due to the loadings, the readings from the strain gauges are epsilon A is 60 microstrains, epsilon B is 135 microstrains, epsilon C is 264 microns. 264 microstrains. Question asks you to determine the max in-plane principal strains and the orientation of the principal planes. Is this question clear? Strain rosette is given. Epsilon A is given as 60 microstrains. Epsilon B is given as 135 microstrains. Epsilon C is given 264 microstrains. Theta A is 0, theta B is 60 degrees, theta C is 120 degrees. Fine. So question is determine the in-plane principal strains at the point and the directions in which they act. Determine the in-plane principal strains at the point and the directions in which they act. Fine. So let's start this numerical. This is not required. This is the question. Data is given to you. So now let's start this numerical solution. Theta A is 0, theta B is 60, theta C is 120 degrees. So first epsilon A equation will be epsilon A is equal to epsilon x cos square theta A plus epsilon y sin square theta A plus gamma xy sin theta A cos theta A. So epsilon A is equal to epsilon x cos square theta A plus epsilon y sin square theta A plus gamma xy sin theta A cos theta A. Fine. Now epsilon A value is 60 microstrain. So epsilon A is 60 microstrain. So you will put the value of 60. Theta A is 0. Theta is 0. Theta is 0. So please simplify this and let me know whether you are getting the same answer or not. Sine 0 is 0 and cos 0 is 1. Sine 0 is 0, cos 0 is 1. G. Please solve it and let me know.
Yes, sir. Getting same.
Okay. So now you can see here, from here you are actually getting the value of epsilon x, that is 60 micron strains. Now next is epsilon b. Epsilon b is equal to epsilon x cos square theta b plus epsilon y sin square theta b plus gamma xy sin theta b cos theta b. ठीक है जी. So epsilon b is given as 135 microstrains. Theta b is 60 degrees. So 135 microstrains. ठीक है जी. 135 microstrains is equal to epsilon x cos square 60 degrees plus epsilon y sin square 60 degrees plus gamma xy sin 60 cos 60. ठीक है जी. And please simplify this and let me know whether we are getting this answer or not. At present, do not put the value of epsilon x. Okay, just simplify this. जी. जी. Did you guys get the answer?
Yes, sir.
Okay. Now the third is epsilon c. So epsilon c is equal to epsilon x cos square theta c plus epsilon y sin square theta c plus gamma xy sin theta c cos theta c. Epsilon c value is given as 264 microstrains. Epsilon x is cos square theta c is 120 degrees plus epsilon y sine square theta c 120 degrees plus gamma x y sine 120 degrees cos 120 degrees. So can you please simplify this and let me know?
Yes, sir.
Now you have got equation 2 and equation 3. Now we will put the value of epsilon x, which is 60 microstrains, in equation 2 and equation 3, and we will simplify these two equations. Okay, I will put the value of epsilon x as 60 microstrains, and then we will simplify this equation. And in this equation 3, I will put the value of 60 microstrains, and in this equation 3, and I will simplify it. Okay, then solving equation 2 and 3 simultaneously, we should get the answers of epsilon y and gamma xy as 246 microstrains and minus 149 microstrains respectively. Please solve this and let me know whether you are getting these answers or not, because this is the plain state of the strain, and from here onwards we will calculate the max what is the principal strains and maximum in plane shear strain. जी, Ji guys, anyone found the answers?
Yes, sir.
Okay. So now guys, we have epsilon x is equal to 60 microstrains, epsilon y is 246 microstrains, gamma xy is minus 149 microstrains. Now based on this, okay, this is your plane state of the strain. We will draw the Mohrs circle based on this, and then we will calculate the maximum we will calculate the principal strains and maximum inference shear strain. ठीक है जी? So let's start the Mohrs circle. So in the Mohrs circle, first step is we need to find the coordinates of point C, and coordinates of your point C are average strain and zero shear strain. So first we are going to calculate average strain. So average strain is epsilon x plus epsilon y over 2. So 60 microstrains plus epsilon y 246 microstrains over 2. So this is 153 microstrains. So average strain is 153 microstrains. Average strain is 153 microstrains. G. Average strain is 153 microstrains, and coordinates of point C will be 153 microstrains and shear strain 0. Now the reference point A, it will have coordinates epsilon x 60 microstrains and gamma xy over 2, that is minus 149 over 2, that is minus 74.5 microstrains. Just keep this thing in mind, that this shear strain is negative. So gamma by 2 is minus 74.5. This is a point to be noted. Okay, so reference point coordinates are 60 microstrains and minus 74.5 microstrains. Next is you need to calculate the radius of the Mohrs circle or the resultant, and the formula is under root epsilon x minus epsilon y over 2 square plus gamma xy over 2 square. So guys, please find the resultant or the radius of the Mohrs circle.
Sir, it's 198.2.
119.2 microstrains. 119.2 microstrains. So radius or the resultant of the Mohrs circle is 119.2 microstrains. Now next thing is we have to draw the Mohrs circle. We have to draw the Mohrs circle. So you can first select the the scales. You can see radius is 119.2, average point is 153. So 153 plus 920, let's say. So this is 273 rough. And on the other side, you will have 153 minus 119. So you will have around 30 something. And over the top, you have minus 120, 120. So You can take the scale 20-20 on both x and y axis, or you can take the scale 40-40. So just in the case of the Mohr circle, the important point to be noted is that on both x, on both y and x axis, we have to select the same scale. So I have selected the scale of 40. So this is 0, 0, origin of your axis. Then 40, 80, 120, 160, 20, 200 to 40 to 80, 320, and over here I have taken minus 40 and minus 80, although whole of your Mohr circle is on the positive side. As you have seen, 119 minus 153, it is 33 something. Okay, and minus 40, minus 80, minus 120, minus 160, यहाँ पे आपको maximum minus 120 चाहिए. Same is there, 40, 80, 120, and 160. You need maximum 120. So this is gamma by 2. This is epsilon normal axis. ठीक है जी, gamma by 2 and normal epsilon axis. ठीक है. So first I will locate the average point whose coordinates are 153 and 0. So on the horizontal axis, I will mark the point 153. In your exam, when you are drawing the Mohr circle, you must use the foot, okay, foot ruler and the compass. Okay, so please try to mark the point as accurately as possible. Okay, because from the Mohr circle you also should get the same answers. ये नहीं है कि आप इस तरह calculate करके answer लिखते हैं and from the Mohr circle your answers are not the same. So from the Mohr circle answer should be same as well. And your reference point A has the coordinates 60 microstrains and minus 74.5 microstrains. So 60 and minus 74. So 40 and 80, average 60 and minus 74. On the shear strain axis, vertical axis, shear strain is negative upwards. Shear strain is negative upwards and positive downwards. So this is your reference point A. This is your reference point A. So you will connect C to A, and then you will open up the compass equal to the radius. Place the compass at C, open up equal to the radius, and draw the Mohr circle. ठीक है जी, draw the Mohr circle. Fine. So now from the Mohr circle, we need to get the principal strains. So the larger value will be major principal strain epsilon 1, smaller value will be epsilon 2. So epsilon 1 will be what you say, one average strain plus the radius. ठीक है जी. So this is somewhat 272.2 microstrains. Epsilon 2 is average strain minus the radius. It is 33.8 microstrains. 33.8 microstrains. ठीक है जी. So please see this. Are you getting the same answers from your Mohr circle as well? Please let me know if you have any difficulty. G, epsilon 1 and epsilon 2. Everyone is getting the same answers for epsilon 1 and epsilon 2.
Yes, sir.
Okay. Then other thing was asked the orientation of the principal planes. Now your reference plane is CA. Reference plane is CA. So we need to move from CA towards CB to calculate the orientation of the principal planes. And this will be in clockwise direction here. So you have to mention clockwise. So can you please calculate this angle? Moving from a reference line CA towards CB, this is your 2 theta P1. And 2 theta P2 is relatively easy to calculate, and then we can subtract 180 degrees minus 2 theta P2 to get 2 theta P1. So this angle is this is 60. So 60 and 153. So 153 minus 60, that is base. Perpendicular is 60. So tan theta, tan 2 theta P2 will be equal to what you say this, sorry, 74.5 over 153 minus 60. So please let me know the angle. Over required angle is 2 theta P1. 2 theta P1. So please let me know angle 2 theta P1, which is the orientation of the principal planes. G. What is the value of 2 theta P1? G. So what is the value of 2 theta P1? The answer with me is for 2 theta P1 is 141.4 degrees. 141.4 degrees. 141.4 degrees. Theta P1 is 141.4 degrees. 2 theta P1 and 2 theta P2 is 38.6 degrees. 38.6 degrees. So that's it for today, guys. And tomorrow we will start these relationships. I will try that in 1 hour lecture we finish all of them, so that we have what to say. In the last week we have the time for the theories, failure theories, which I have told you to study earlier. So guys, thank you very much for your time. There were only 28 students in the class. Let me download your attendance.